Hello, this is Mr. Froelich. Today we will be covering Earth's energy budget. One of the things that we've already covered in this unit is that energy in space can be exchanged between different objects in different ways. Once an object has energy, there are basically three things that object can do with it. That object can absorb the energy, reflect the energy, or transmit the energy. Now, what we're covering today is not the basics of that, since we have already discussed that in earlier screencasts. What we are talking about today is the budget of Earth and its energy. So in order to cover this, what we need to do is learn about a basic budget and how it relates back to the transfer of energy. So in real life, we will get things from doing work called a paycheck. Now, in this case, money will represent energy. The more money your paycheck is, the more energy you receive. Now, it would be very simple if I was able to keep all of the money from my paycheck. But in reality, before that money is ever in my hands, some of it gets lost to taxes. So those taxes are taken out before I ever see that money. After that, I'll get a deposit in my paycheck, in my bank account, and that will be the money that I can spend. Now, in a month, I will spend my money on a bunch of different things, but basically, I have to pay my bills, I have to buy food to survive, I will put some money into savings, and I will maybe give some money to someone else. In this case, I have a picture of Angie just to represent that. Now, the actions of doing different things with my money in terms of energy can relate back to emitting that energy, which means I have the money, I have the energy, and I spend it or give it away for something else. I don't get anything else in return for this. I could absorb that energy or that money, and in this case, when I save my money, my bank account goes up. Just like when I absorb energy, generally my temperature goes up. Or I can transmit that money, which means I have given some of it away for someone else or something else in space to do with that money or energy. Now, the last one is reflection, which is sort of like what those taxes are. That money is given away before I ever have a chance to spend it. So in the terms of energy, when something is reflecting energy, it never actually owns it. All it does is bounce it back in a different direction. In terms of Earth's energy budget, it will get a little bit complicated when we start to talk about the different ways that energy is transferred across the atmosphere and the ground. So one of the first things that I want to highlight is that 100% of the energy that Earth gets is coming from the sun. Now, not all of that 100% of that energy will actually make it to the ground. In fact, on its way down, a good chunk of it will actually be reflected by clouds. So 23% of that original 100 is reflected away. Also, the atmosphere itself will absorb around 23%. And the ground on average across the entire globe will reflect about 7%. So this would be things like when you see light being reflected by snow or water. On average, it's about 7%. So that leaves only about 47% of that original solar energy to be absorbed by the ground and actually heat up the planet. Next, we will discuss what the Earth does to emit solar energy. So one of the things that tricks most students when we discuss this is that Earth takes in about 47% of energy from the ground, but it's somehow able to emit 116% of its energy back upwards. This will become more clear later on. But from that 116%, only about 12 of it makes it to space. So, of the energy that's being taken in by Earth, 12% is emitted back out to space. We would know that as, or feel that as, heat. On its way up, some of that energy is then reabsorbed by the atmosphere. So 104% of that original 116 emitted by the ground is absorbed by the air itself. Now, this would happen in the form of greenhouse gases, which we've already discussed as a way that the air acts like a blanket, trapping heat, sending it back downwards so that Earth is warmer. Of that 104%, some of that energy is emitted to space. So when a greenhouse gas absorbs energy and emits that energy in the form of heat, it is emitted in all directions. So some of that energy is emitted upwards towards space. The rest of it is directed towards the ground. In this case, 98% of that original 116 makes it back to the ground. The last thing that we need to cover when we are discussing the energy budget is that some energy is released by large bodies of water like oceans or lakes in the form of latent heat. The way I describe latent heat to my students is that it's energy that's built up inside of that body of water that is emitted. So in some ways, it's sort of like hidden energy. Now, one thing that we need to do is we need to make sure that this is a balanced budget. So there are 3 places where the budget needs to remain balanced, otherwise we would see drastic changes in global temperature. One of them would be the incoming energy. So back to our previous budget example, this is like your paycheck. So we said 100% of the energy that we get is coming from the sun, just like 100% of my paycheck comes from the school. Now, as I get my paycheck, that money is going to be spent in different places like my bills or my food or gas in my car or whatever. In terms of Earth, that 100% is spent by reflecting by the clouds, 23 absorbed by the atmosphere, 7 reflected by the ground, and 47 absorbed by the ground. So if this is truly a balanced budget, that 100% has to equal 23% plus 23% plus 7 plus 47%, which it does. This will represent the incoming energy equaling the outgoing energy, and that is the most important part here. When you have a balanced budget in real life, the money that you get in your paycheck will be balanced with all of the things that you spend it on. You can't spend money that you don't have. The next place where we will examine the balance of Earth's energy will be the energy in the ground. So, in order to do this, we have to take all of the incoming energy and make sure that it equals all of the outgoing energy. So when I look at energy that is going into the ground, that would be the 98 and the 47%, which are both absorbed by the ground. And that has to be equal to the 116 and the 29% that are emitted by the ground. And in this case, that represents the incoming and the outgoing energy. And again, this is balanced. Now, the last place where we must examine the balance of the energy is the energy that is in the atmosphere. So in the atmosphere, we will have the 23 and the 104%, which are both absorbed by the atmosphere. Now, it is implied that the 29% emitted by the ground as latent heat is also absorbed by the air. So I have 23 plus 104 plus 29 as my incoming energy to the atmosphere. My outgoing energy from the atmosphere will be the 58% and the 98%, which are then split off. Again, these numbers are balanced, and this diagram, although may be complicated, shows that the budget of Earth's energy, the solar heat that is given to the planet, is balanced in all areas, meaning that as a globe, our average temperature should not be going up or down. Now, I will say that this is an ideal situation with numbers that have been rounded and simplified. This is not the case for every location on the planet. And of course, our temperature across the globe does change day to day, week to week, year to year. And there are other factors that control that. Later on in this unit, we will discuss some of these things in detail. Thank you for watching.